Hello dear friends of physics, I'm Wolfgang Bock from Germany again, and today we look at waves. Waves, why not electromagnetic waves? Because following the Sekus principle, there's no electromagnetism in waves. Waves are waves and nothing else. And I try to prove it here as good as I can, and keep watching. This is a wave evolution diagram that I designed, where you can see the speed of the wave and the frequency of the wave, and here is the virtual size of the medium used. The medium used has effect on speed and frequency. And if you have a perfect medium here, this is the resonance of the virtual particle used. If the virtual particle is larger than the wave, the length of wave, then the speed keeps being, but the frequency goes down. If the virtual particle is smaller than the resonance, then the frequency keeps, but the speed of the wave goes down. And the speed of the wave goes down to a point where the virtual size cannot support the amplitude anymore. And at this point of break, the speed keeps being while the amplitude drops. Yeah, I try to prove it, so keep watching. So let's generate a sea quake in a deep sea, depth 5 kilometers, duration 20 seconds, and with 1 meter per second lift. But the lift is not that. When the length of a wave from a duration of 20 seconds, that means with light speed used, 20 seconds light speed is 6 million kilometers. There's no natural particle that fits 6 million kilometers, so the virtual particle used is the ocean. At this point with a 5 kilometer depth, and the 5 kilometers with frequency to light speed is the effective speed to the light speed. So let's try it. The effective speed is 5 kilometers multiplied by the frequency multiplied by the density. This gives us an effective speed of 250 meters per second or 900 kilometers per hour. This is a real speed for sea quake waves in deep sea. If the sea is deeper, it is quicker. If it's more shallow, it's slower. But what happens if the wave hits coast? When the wave hits the coast, the depth of the rudder decreases, possibly to 100 meters. The effective speed of the wave, 0.1 kilometer multiplied by frequency and density, gives us an effective speed of 18 kilometers per hour. I do not know if this fits completely, because at some point the depth of the water cannot longer support the amplitude. And when this happens, when the amplitude cannot longer fit by the virtual particle. Then the wave itself starts being alive, I think. The wave keeps speed and frequency, but the amplitude goes down. It's like the water flows on the coast. There is no water, but the wave keeps itself running with decreasing amplitude till it's finished. Yeah, that's what happened at the coast with a break point from the wave where the amplitude cannot be so longer supported. Then everything keeps being and the amplitude goes down. The seaquake, the wave of the sea, fits reality calculated this way. The other way, the wave on the tectonic plate, using the diameters of the tectonic plate, also fits reality, but the point of break on the tectonic plate is affected at a much higher speed. So normally the density of the tectonic plate don't fit the amplitude of 20 meters, so it's affected directly and goes down in amplitude with the distance. But what is with light? We have a length of wave of nanometers and almost no amplitudes. And yeah, why is light? How can I decrease light in speed or in frequency? If the space is full of quants everywhere, the speed, the light generated has to move through the quants. And the quants are mostly larger than the length of wave and the amplitude generated. So, moving through the quants, the light has to shift to red. This is only, at this distance from the sun to here, it's only a very minor part, but you can see it when the light hits atmosphere. When the light hits atmosphere, it has to move through atoms. In space, there are only quants, they are small, and light is fast. Reaching the atmosphere, the medium changes from quants to atoms, but not atoms. There are everywhere atoms. There are no quants, lonely quants anymore. There are only atoms inside the atmosphere. And the atoms are elements and electrons. The electrons are smaller than the length of wave, while the elements are larger. So the light loses speed, a bit effective speed. When it's transported, it goes to the electron, which is smaller. Smaller means speed is reduced. But from electron, it changes to element, proton, and proton is larger, so the speed is kept and the frequency goes down. Leaving the proton to electron, speed goes down, but goes up when reaching the proton, goes down when this is a up and down in speed, and but only down in frequency. the frequency can't be raised again. So we can see it when it's in dusk. When you look in the evening, sundown, then you have a large red sky. This is because the distance the light moves through the atmosphere is larger than at noon. At noon there's only a minor shift to red because of the high energy of the high frequency energy of the light. There's more ultraviolet lit at noon and it's less affected, but through the distance the whole light changes to red, so you can see the red sky. This is also affected by rotation of the Earth. The same effect is in the morning, but it's not that good to see because we are moving towards the sun, so the effect is less. Yeah, we know it. Atmosphere goes red in the evening and the morning. This is a redshift of the light. Also, this is affected by the water. If light goes into the water, at the first few meters, there is a blue shift. The white light changes to blue, and when you go more and more deep, the blue disappears, the other colors disappear, the red is allowed to disappear. But is there no wave anymore? No light? Yeah, no light, but the wave keeps being. If you go deeper and deeper and deeper, the wave have to change more and more and more to lower frequencies. So possibly at some point in deep sea, when looking at noon to the sun, you should see it as a radio or a microwave or something. Yeah, I think that is not tested, but it should be. But how light is generated? When there are no photons in a Sekus theory. Light is generated by an energetic difference, as I show you. Light is generated through the difference of the virtual particle in the sun. Why are there large particles? Because of the spinning quantum rules, which centering the largest particle in the center. So there is a large particle bordering a quantum of space. The quantum is very small because it's heated from the sun. So the frequency of the quantum is high and the virtual particle is very large. Let's make an example. The frequency of the A quantum is 51 and of the virtual particle is 1. Then there's a difference of 50. And this difference is the wave that it caused. So the wave moves in this direction, 50 Hertz, and in this direction, 50 Hertz. But looking at our wave evolution table, this quant is a little bit larger. It holds 51, but we only have 50. It's a little bit larger than the difference. So a little bit larger means speed is kept, but frequency drains a little bit, from quant to quant. While this is much larger than frequency, frequency goes down dramatically. Now, this is the light we see, because this move upwards, this move towards the center of the sun. This is the light we see. So, think about it, have fun, and hope you enjoy. See you next time for black holes. Yeah, keep it. Goodbye.